Welcome to this walkthrough of the script I've put together on simulation for our course. So let's start by getting oriented. We are going to be doing a simulation based on our data set we've been working with all along. And we are going to be looking at the PACU, our Post-Anesthesia Care Unit. So patients who come from the OR usually recover before they move on to their next care area, whether that's home or the hospital, in a PACU. And so we're going to get started with the basics by getting the libraries that we need, including the Google BigQuery, so that we can connect and start asking questions of our data. You're going to need to authenticate. That's what's going to happen here. You'll see that I'll be asked to allow that authentication. I'm logged into my Google profile, so that is what's going to give me access to the Google dataset. Make sure that you have that going on. And then we can move into something actually useful. We're going to start by grabbing information from our OR table, running a query and loading the 934 OR encounters that we have there. We're going to normalize some of the timestamps so that we can use them and get them into a format that's just a little more communicative. And let's go ahead and look at the top of that data. So we've got this OR case for this patient, and we see what they were there for, the team that did it, and then their check-in time in the room, procedure starts, procedure ends, out of the room, and they arrive at the PACU. So we've got a lot of different information that will allow us to take a look at this environment. Let's go ahead and just do some basic discovery, pulling out the data to see it. It looks like the majority of our cases are elective, but we do have some that are urgent. That's interesting, and we kind of bring that into our decision making in some of these later steps. I think maybe in the optimization, not necessarily here. We will go ahead and get a length of stay column in there because we don't necessarily have it. We're going to be looking at the time from the PACU discharge time, or PACU arrival to PACU discharge, basically. It's going to be our PACU length of stay. And let's look at the variation of that. Yeah, we've got some nice variation like you would expect. There are people who do stay long, but it doesn't happen that often. The majority stay some reasonably consistent number of minutes, but there's some spread around that. So it's just getting to the data, being able to see it. And the first thing we want to do is go ahead and see a single day in the PACU and understand that activity. I want to go ahead and see some of the busiest days. And so this is some quick code to get me to that kind of an answer. What days had the most cases? And then to observe one of those to see how many were elective and how many were urgent. So here's a really busy day with 8 cases in this small hospital, a couple of urgent, mainly elective. So now we move on, and we are going to want to see what does that translate into for occupancy within that PACU. We have the timestamps. We know when people arrived and when they left, and so we'll set those out. We know the start and the end, and we can use that to create a census, essentially, over that date, and then take a look at it. So we can see here what happens for the occupancy of our OR over a set of time, so that we can see by the time of the day, all on 4/17, we had one person in, from 10 to 11, and then they're discharged, no one's there, and then we go up to 3 people in for a short time in the 12 to 13 hour. And so this is what we're seeing on a really busy day in our PACU. So now you've just sort of seen the data. We've got it set up. We've got a length of stay on there. Those timestamps allow us to kind of look at what has that meant for occupancy. And so next we're moving on to, one last step of just sort of seeing the data. Let's get the capacity worked in here. I'm going to say right now that we have a capacity of 3, intentionally kind of small to make this simulation meaningful to talk about when are we at or over capacity. So on this particular busy day, we did not go over capacity, but you can imagine because of the variation of how cases are scheduled and when they start and how long they stay in our PACU, there can be times when there are higher occupancy than this. So that's what we're going to simulate is how could this same schedule have looked if it had some of the normal variation that we experience. That's where we're we're moving on to. So we're going to build a basic Monte Carlo simulation, just a repetitive simulation to look at how could this have been different based on variation that is possible in the process. So we will go ahead and sample that length of stay information that we saw before and see the overall, there's 934 examples that we have there. We'll use that to be able to sample from for the variation in our simulation. So we are going to rerun this day over and over to see the different possible max capacities that could have happened based on that variation in length of stay. So we're going to start by just getting a copy of our data so that we don't mutate or make an issue with the original. Call it SimDF. We've got the length of stay in there. Then we're going to build a new discharge timestamp, and we're going to do that by adding in a time delta, which is just end up going to be a random pull from our experience of length of stay in the past. So we'll use that length of stay distribution, which you saw up here, and we will just randomly pull from this distribution. We'll say, all right, let's say they were admitted exactly as the case was listed, but they had a length of stay of 20 minutes only. There aren't going to be many times as we pull randomly that's stuck to this distribution. That won't happen very often. Most often we'll be pulling in this range, 60 to 100, and a very few times we'll also pull in this extreme range. So that's going to take that same day and just repeat it over and over again. And so we are going to compute the occupancy each time that we do that and store it to a data set to be able to ask questions about later. So let's go ahead and get that run and go ahead and see what happened. That one simulated day with a max occupancy of 3 had 0 minutes over capacity. But now let's run the simulation 200 times and see some examples. In run 1, we had a max capacity of 3 with 0 minutes that would have been spent over capacity. But take a look at run number 2, because we must have pulled differently on that previous distribution of length of stay. We end up hitting a max capacity of 4, and we were at that for 20 minutes. We were over capacity for 20 minutes. So the overall data set is much bigger. This is just the head of it so that we can see. So we can ask questions of that data set, this simulated future of what could have happened, to see how often did we hit these different levels of maximum distribution. It looks like most time we are at 3, but there's some probability of going over, exceeding that capacity. So we can observe that result in our simulation of 200 examples. We can also come here and observe the other item that we kept, which is how long did we spend over capacity. If we are at 3, we're not at over capacity. And so we've got a lot of our observations in this simulation where we spent no time over capacity. So that's the most likely scenario. But there is some chance of spending as much as 50 minutes or an hour over capacity based on just the regular variation that we experience in length of stay of the PACU. So now we've got this more probabilistic endpoint. Instead of a prediction of this is yes, you will go over capacity or not, we've got a large data set, 200 examples, where we've used regular variation to look at how often would we have gone over capacity. So we get to this nice simple answer of that sort of caseload of 8 cases where 2 of them are urgent, has a 33% probability of being over capacity. This is the type of thing that really helps us make a decision as we are trying to inform things more with more context, more information, instead of the simple yes, no call, trust us, we check the data, it's unlikely. This is saying we've used history to inform the variability that's possible within our PACU stays. And if that sort of variability is experienced, 33% of our simulations end in an overcapacity situation, and the balance of that, right, 66%, do not. So that helps us make a decision with just better and more information, given that we don't always experience the average. We don't always experience that best case scenario. So thanks for walking through that example with me.